back to my YT channel. Again, welcome back for my segment number 2. But before that, I have to drink coffee and eat banana. Wow, which is the passion. Kaloka banana talaga. Kaloka. Diba mga palangga? Init yung coffee mga palangga. Oy, in fairness. Nakakaloka! Ay, nako! Char. Wait for a while, guys. I have to live stream also in my Facebook account. Okay. So, simultaneous live streaming tayo po ngayon, mga palangga. So, second segment of problem solving in terms of heat energy, enthalpy change, heat content. Ganon. Okay. Wait for a while. In fairness, nakakaloka. Okay, mga palangga kung hitad. Tempasa. Hello. Okay. Ganon. Okay. Hello! Hello mga palangga! Welcome back to my Science World! Science vlog, particularly general chemistry. Okay, the backbone of all pure sciences. Okay. Oh my gosh. I will read now the problem. Okay. In fairness to my FB Live, friends out there, you can see now the content in the whiteboard, or just very small. Okay? Klaro, di ba? Okay. Sugod na ta. Let's start! Okay. Let the fire begins. Okay. 4.82 grams. Okay. 4.82 grams of an unknown metal is heated to 150 degrees Celsius and then placed in 35 milliliters of water at 28.7 degrees Celsius, which then heats up to 34.5 degrees Celsius. What is the specific heat of the metal? Oh my gosh. Okay, already discussed it a while ago, right? So, specific heat ang ipangita mga palangga. Diba? So, isang formula sa specific heat. Okay. So, we can use this formula. Formula Q is equals to M CS delta T. Okay. And then we have two here substance. Okay. We have the water and the other one is unknown metal. Water and metal. So water and metal. If you try to say this in general, this involves heat transfer. Okay? Heat transfer from the heat of the water to the metal and also the metal to the water. Something like that. You get the point? So there's heat transfer. And then, what we're trying to do here, we need to solve individually the heat content of the water and the metal. Something like that. For example, if I have here, this is my glass of water. For example, only this is coffee, right? And then this is the thermometer, like this, inside the water. And then there is a metal. The metal is already heat on the other container, something like that. Okay, and there's a temperature already. And then when it will come to the glass of water, the heat will be transferred. The heat will be absorbed by the water. It will be released, the heat of the water will be released to the metal, things like that. Okay, so very clear, right? Heat transfer. Then this is gonna be happening like this. Okay, like that. Even though you will not hit the metal, okay, as in the original temperature. If you dip that on the glass of water which is already hot, then the metal will become hot also. That is heat transfer. The heat of the water will transfer to the metal. You get the point? Or reverse, if you hit the metal, the water is cold, then it will have the transfer of the heat to the water. Because the heat transfer driven by from higher temperature to lower temperature. So it's gonna be adapting the temperature of the hottest one or the hot substance, which is the metal. Things like that. There's a heat exchange between the two substances. Okay, ganon. Or heat transfer siya, guys. Okay, saan ba ito compute hindi kayo na? Char! Okay, ito ng compute ton. So, mag-compute ako sa itong coffee. Wow. Hello mga palangga! Welcome to the science vlog talking about heat transfer, heat exchange, heat capacity, specific heat capacity, molar heat capacity, enthalpy change, heat content, heat reaction, ganon, and thermochemistry and thermodynamics and thermochemical equations. These topics will be linked together, will interconnected with each other. Okay? Like that. Oh my gosh! Mukha sa kung yung saging. Char! Hello. Hello mga kapatid! This is only my lunch, banana. This is only my lunch, one banana. Okay? And I will survive for this. Charot! Okay. O diba? Oh! Banana, rich in potassium and calcium, magnesium. For bone health. Charot. Strong bones. And then for, repair of the dead cells. Charot! Talaga, dead cells. To prevent, the osteomalacia, the softening of the bone, and the osteoporosis, the weakening of the bones, just eat daily alatul on daily basis, banana. Okay? Because that is good for the bone health. Okay, my mother, shout out to my mother. Hi, Mama Lumin. She always ate, banana every day. And then she's now old, but her spinal column is not curved when she walks. Okay? Because that's an identification that your bones are not properly, cared. Because, then you have to buy rich in calcium milk also. But it's better you should eat banana. Okay? While you are still young. Char! Milk and banana. Maglakaw, bako kay maglakaw. So late na kayo na sila niinom og mga milk. When they are young, they don't love to eat banana. They love to eat cake, spaghetti, ganganan. Okay, mga meaty substances. They don't like fruits and vegetables, sure. Okay, na mga gabok, mga buko-buko, whatever. Ganon. And also, when you eat banana, it makes you younger. Charot, just like me, I'm younger. Charot! Charot lang. Charot lang ha. I'm younger because I have more responsibility. Okay? Diba? If you have no responsibility, what I mean, wala ko'y gibuhi nga mo. I'm not really mandated to, it depends on me, something like this, okay? Siguro kung nagkakit kong anak, I will not look also like this. Siguro namunot na po niya ako mga reali, akong papangig o whatever. Okay, ganon. And then, muglo imong skin if you are not having so many responsibilities in life, there's so many stresses in you, right? Ganon, mumatter mo na siya guys, ang mga stress, you always feel sad of the of the bad things around you, and especially for the failures happening around you or you yourself. Always you have to forget that one, and think positive. Though it's hard to think positive sometimes, but you have to like that. Okay, that's perception. You get the point? And then sometimes it's okay not to be okay, because if you force yourself to be okay and then you are not okay, that's not also good. It's not good for the heart. Heart, heart is more on acceptance, freedom, liberty. Ganon. So you release all your heartaches, and then your heart will be happy, and and the sadness will be removed, something like that. And then for example, if you will express in social media, sometimes that you don't like, and you express it, and then your heart will be happy if you express that, something like that. But of course, consider also the impact. But of course, you're responsible in every post that you've made in the social media, right? Be sure you can stand by it. Ganon. And properly researched, so that you can back up with facts, and then it will be traced. Something like that, okay? Nakakaloka. And then please read also the article of cybercrime. Okay, and then libel law, so that it's very easy to you to post on social media because you know already the content of that law. Get the point? Ganun. Di lang tayo patakagyawit. Okay, na if there's somebody who will comment that off, libel case na yun. It's not like that. Study first the law. What is really a cybercrime? Because you will there's a technical there, not only general telling that if the person having a bash statements or negative statements, that is automatically under cybercrime or libel cases. No, there's a technical criteria there. Okay, go over it. Read. Okay, before ka mo yawit sa social media. Before mo badlong sa inyong isig kaingon, basaha sa ninyo ang libel cases, what is that all about, and the cybercrime law. Okay? Para klaro. Get the point, mga palangga. Para di mag-away, di magtubag-tubag, magpungot mo sa social media. Diba? Ganon. Kapit na akong coffee, nahulot na siya. In fairness, mga palangga. Thank you so much for watching, Mr. Maru Vectorilio. Thank you kaayo, mga palangga. Okay. Wow. Shout out kanimo, Maro. Okay, guys. Solve na gyud ta. Naman na siya. Okay, mga palangga, kung hitan.
The Bluetooth device is ready to pair.
Okay, the first thing to do is to use this formula. Q is equals to mass to the specific heat capacity times the change in temperature. Okay, ganon. So water first. Okay, water H2O. Now, analyze the problem. 4.82 gram of unknown metal. So this is the mass of the metal. Put that here. Mass of the metal. 4.82 grams. Okay. And then it's heated to 115 degrees Celsius. So this is gonna be the temperature of the metal. So if it's heated to 115 degrees Celsius, it's gonna be the final temperature, right? Because it doesn't specify the initial temperature. Okay, 115 degrees Celsius. And then place in a 35 ml water. There's a container here which is 35 ml water. Okay, H2O. And then, okay, ganon. And then at 28.7 degrees Celsius. Okay? Like that. So meaning to say, the initial temperature of water is this one. 28.7 degrees Celsius because it is placed in 35 ml of water at 28.7 degrees Celsius. So originally, so this is the T initial of water, 28.7 degrees Celsius and 35 ml of volume. So volume initial of water is 35 milliliter, right? Ganon. Now, which then hits up to 34.5 degrees Celsius. So meaning to say, since the sentence is continuation, meaning to say, and there's comma, this 34.5 degrees Celsius is the final temperature of the water. Okay, take a look how the paragraph or the sentence is being phrased. It matters a lot. Okay, like that. Get the point? So this is T final is 34.5 degrees Celsius. Okay. Now the question says, or ask, what is the specific heat of the metal? Okay, so the CS of the metals, let's say CSM, because specific heat CS plus M metal. Okay, so question mark. Ganon. Now solve individually the heat. So basically this is actually heat absorbed is equal to the heat released. Okay? So we need to say the heat absorbed by the water, because heat absorbed by the water from the metal. Why? Because the metal is having a higher temperature, which is 115 degrees Celsius. So we need to say the heat absorbed of water from the metal. So Q H2O is equal to the Q of the metal. Now let's apply the exothermic and endothermic so that we can have the sign. So heat absorbed by the water from the metal. So if it's absorbing, so we need to say this is negative. Negative Q ang water. You get the point? Okay, one niya, absorb. Take note. Let's think it over. Absorb. No, it's not absorb passive. You have to think, everything you put, you have to think. Because, this requires analysis. Okay, this topic requires analysis. You have to think something like that. So, if the metal will release the heat to the water, so this heat will become Q because the heat is taken away, meaning negative. So, negative Q metal. Okay, negative. Okay, because the heat of the metal is being taken away or released to be given to the water. This is the final principle. The water, the heat of water absorbed is equal to the heat of the metal released. Okay? Anak siya. Okay, now solve individually the Q. Okay. Let's erase this. Okay, ganon. Okay, hugok akong nagsulat-sulat guys, no? Mujib na akong, when I was in college, this is my, this is my fault all the time. Very dirty, too much erasures. Like that. Okay, and then, okay, Q, water tank. Water so good. Oh, water. Q, H2O is equal to the mass of the water, specific heat of the water, and change in temperature of the water. Now, if you write the formula, you should think first what is available on the data. And then second, what is available in the standard. And then third, what is available to correlate to other formulas. It's gonna be always like that. Again, first, look at the data that could be substituted directly, like that. Second, look for the standard that could also be substituted directly. And third, look for the correlation with other quantities and formulas so that before you apply here. Okay? Or what I mean of standard, constants, tables, and graphs. Because there are a lot of graphs and tables for all physical and chemical properties of inorganic liquids and organic liquids, and also gases, or mixture or substance like that in the in the handbook, in our handbook. Okay? I don't see, kasi I don't see what is the handbook of mechanical engineer. I don't see also what is the electrical handbook, electrical engineer's handbook. But for us, we have chemical engineer's handbook. Okay? Paris chemical engineer's handbook, in which we use that every time. Okay? So that's why I told you it's in the handbook. Okay? Like that. So, water. So Q water is equal to the mass of water. How much? Take note for the here. Is there a mass given for the water? And then place, for example here, then place in 35 ml of water, but the volume is given. How can you get the mass of the water if the volume is given? So that is the correlation of other formulas, what I mean, before you substitute, right? Before in my introduction. First, substitute first directly, if given. Second, put the standards through tables, through graphs. Third, find a quantity that is correlated to other formulas. This is the example. We have the mass and we don't have the mass here. So we need to correlate to other formula so that we can get the mass. What is the closest formula to be used to get the mass in relation to the volume? Think, in general chemistry lecture. Meaning to say, you will look for a formula that is simplest formula that doesn't involve too much quantities. First, that is your priority. Second, na itong mga mga. Second, go over to the formulas that have more quantities, but go to the lesser part, okay? Because it will trouble you also to get another quantities and it will add headache to you. You get the point? Okay. For example, I have this mass. So the closest formula that I will be used is to use the density, the formula of density. Okay, though I can still compute the mass through different, percentage by mass, like that. I can compute that also through molar mass. Okay, I can compute that also through flow rate, volumetric flow rate, like that. So, things like that. But we will go to the simplest. Density is equals to mass over volume. Okay. Take note, guys, we have 35 ml. Okay. 35 ml, guys, you should memorize that the milliliter is just equal to cubic centimeter. Okay? Again, milliliter is just equal to cubic centimeter. And cubic centimeter are related by small cc. It's not specified in words. You get the point? cc, meaning cubic centimeter. Some books also have CU dot cm dot cubic centimeter, but a lot of books reflecting CC only. Okay, and some books also cm raised to the power 3 because it is cubic centimeter. Which is which? Easy for you, but we prefer CC na lang yung siya. Okay, so this is also equal to 35 cc or cubic centimeter. You get the point? Ganon. The density mass over volume. Okay. Now, your volume is M. So, your density to be used also is in terms of ml. Okay? Like that. So, solve for the mass. Math. Crisscross. And mass is equal to density times the volume. Now, this is the issue here. Until now, guys, I did not understand why all problem solving always use the 1 gram per ml, the density of water, to be substituted in different problems. You get the point? Since we know in the fact that the density will be dependent on temperature during the experimental analysis, we can get this density at this temperature. We can get this density at this temperature with pressure also. Operating conditions, it's always temperature and pressure, we can obtain this density. By having temperature and pressure, we can also obtain the viscosity. By having the temperature and pressure, we can obtain the melting point, the freezing point, things like that. And then here, okay, why we always use 1 gram per ml? Okay, in fact, we have a lot of temperatures here. 115, 88.7, 34.7. So, di ba? Sometimes, di ka kasabot. Sige na lang. We should follow what is really practiced. in engineering. Okay, so let's use, I'm just only asking why, and I want anybody to answer to me now. Because as what I understand and memorized, this 1 gram per mm, 1 gram per cc, 1,000 kilogram per cubic meter, 62.43 pounds per cubic feet are all the units of densities of water at 4 degrees Celsius as the reference. Get the point? But in this problem, there's no 4 degrees Celsius reference. In fact, 150, 28, 34. And then in the computation, we will use density 1 gram per ml. So it doesn't match, right? I need Antoine Lavouchon or any chemists in front of me to explain why. Nakakaloka. Just like asking any scientists why adding hydrogen gas and oxygen gas will become a liquid. Right? I asked that questions long time ago. Okay, because to become a scientist and to become an engineer, you have to really think why like that. Okay, in science, I'm specifically science now. Okay, not English, not politics, not sports, not safety. I'm referring to science only. Okay, because this is I love the most, pure science. Okay, so if you add gas and a gas, then why the gas is liquid? Now answer me Isaac Newton. Answer me John Dalton. Answer me, different chemists. Okay? Mr. Aufbau, Mr. a lot of scientists. Explain why. So there are things that cannot be explained. The same thing with this. Right? Why using the 1 gram per ml density in which that is taken at 4 degrees Celsius. But in our problem, we have a lot of temperatures here. Why using this? Because it's temperatures in actual. And remember, this 35 ml also is actual in water. Okay? Sorry, malibog ka, pero sige na lang. Okay. Okay lang siya if no temperature, we can use 1 gram per ml. Of course, but in here, it's not the temperature kasi. Okay, so let's follow na lang what is in the book or in the references we have. So, mass is also density times volume. We need the mass sa akong heat. Right? So mass is equals to 1 gram per ml, the density of water, times the volume 35 ml. So cancel, mass is 35 grams also. So your mass is equal to 35 also. Okay? You get the point. Even though you put 100 ml, 2000 ml, 250 ml, this also equal to the mass because the density is always 1. You get the point? So, if this is 180 ml, it's also 180 grams. Like this, blah, 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 unless the density is given here specifically. Okay? There's no density here. That's why we assume the standard. Now, like this. This is also unusual because the formula is mass and then they give the volume. Okay, things like that. Anyhow, it's easy to manipulate, right? So mass is equal to 35 gram. Okay. Specific heat. Okay. We should memorize at least 2 specific heat capacity of water. Or memorize the 1 calorie gram degree Celsius and 4.184 joules per gram degree Celsius as a specific heat capacity of water. Okay, ganon. At 25 degrees Celsius. Ambient temperature, right? Am I correct? Or standard temperature. Okay, something like that. So we have 1 calorie. Okay, or you can use also the 4.184 lang. So it doesn't matter. 4.184 joules. Okay, gram degrees Celsius. Times the delta change in temperature for the water. The water is here. Is in the ml of water, initial temperature of water is 28. So final temperature minus the initial temperature, we have the final temperature of 34.5. We have the initial 28.7. Subtract that one because this is delta change. Take note. If there's delta change or triangle, you have to subtract. If there's no like that, then you don't have to subtract all the time. The same as the general gas equation of ideal gas equation. The temperature there is not the change in temperature. It's only the capital T. You get the point? In the PV and RT. It's not a change. Be careful also. Here, there's a change because there's a triangle or the word T, delta T, something like it. Okay. Now, 34.5 divided 57. I cannot use my brain cells for that. I have to use the calculator. Okay. Ganon. Sabi mo mga okay. Okay. 34.5 minus 28.7. Ganon. So we have a difference of 5.8 degrees Celsius. So 5.8 degrees Celsius is the temperature difference. So put that in a delta T, 5.8 degrees Celsius. Now, simplify. Cancel what is being cancelled. So gram, Celsius, Celsius. What will remain is the joules. 4.184 joules. So the heat of water, okay, is being absorbed by the metal. So, okay, is calculator is ganon. So 5.8 times 4.184 times 35 is equals to, again, 4.184 times 5.8 times 35. So 849. So this will be the joule. 849 joule. Water. This is the water. Now, what is the formula of the metal? Q metal also. Q metal is equals to the mass of the metal, and the mass of the metal is 4.82 grams. It's mentioned already. So 4.82 grams. Okay. Then, what is the specific heat capacity of the metal? In which this is our question. See, what is the specific heat capacity of the metal? So put CS. Okay, and then there's still delta change in temperature. What is the change in temperature of the metal? Look at the problem again. 42 grams of unknown metal is heated to, meaning to, take note the word preposition. To. To meaning final already. You have to take note the word from, to, by, with, on, and, because it's very important in solving problem, prepositions. Especially thermodynamics because they are state functions most of the times. Initial and final states. Not so much in general thermodynamics. Be careful because the sign is very important there. Science. S-I-G-N-S. Okay? Like that. So, okay, 115 is 2, meaning this is the 150, this is the final temperature of the metal. So 115. Now what is your initial temperature of metal? It's not mentioned, right? It's very clear it's not mentioned. But take note, you are mixing the two in the container of the water. So meaning to say, it will also receive the temperature of the water. Get the point? Okay? So how can you say that? Okay? It can receive the temperature of the water. Unsa man ang atong isubtract ni higayon na. Take note. Think. Okay, then ka temperature na kapilian ha. Either 5.8, 28.7, and 34.5. Take note. Again, English. 2. And we're asking for initial for the metals. It is not. Right? And then at 28.7 degrees Celsius, this is the initial temperature of the water. Okay, 28.7. So this is the initial. So the initial temperature of the water will also be equal to the initial temperature of the metal because they are not in equilibrium. They are transferring the heat or heat transfer process. This is heat transfer through, heat transfer through convection. Meaning to say, the molecules are being transferred from liquid medium. Okay? Liquid medium to solid medium to liquid or gas. But if it is a solid liquid siya, that is conduction. Okay? Katong mga insulation, calculate the heat of the insulation materials, and then inside the diameter of the chuba-chucho in a building, na i-calculate mo ang heat. Kabantay mo, ito may mga thermal conductivity nga problem. Okay? Lahat po siya, mo to siya mga conduction chuba-chucho. Solid medium siya nga heat transfer. You get the point? But this one is more on the liquid. Okay? You get the point? So this is convection. Correct me if I'm wrong, huh? Okay, because this is liquid and gas. There's no gas, but this is liquid, sure. Of course. Okay, and then the liquid to solid because it's a metal. Okay? And then solid to solid only is the conduction. Okay, correct me if I'm wrong. If I'm wrong. Okay, something like that. Okay, so 115 minus 28.7 ang initial sa metal also. Okay, dito yun ang 34 ha. This is ang 5.8 because the 5.8 is for the water difference na siya. Temperature talaga siya. So 115 minus 28.7 mga palangga. Minus 28.7 mga palangga. Okay. 28, 115 minus like that. Okay, okay. So 80. So again, you have to take note also, huh? Because most of the times, guys, what will be in error here are the temperature. Using the correct temperature will matters a lot here. So temperature changes in this problem it's a great influence to to solve correctly the problem. Now, again, take note. Okay? Let's analyze again the temperature. Okay? We want to make sure ano ba sila kung solve? Okay, pa ako na nag-solve daan para dali ka solve, no? Okay, so ang Q sa metal 4.22 times the specific heat times 115 minus initial sa metal. Ato sa analyze pa tayo, guys, ha? Okay. Is placed in the thermal water at 28.7 degrees Celsius. So this initial for the water. Okay, water. Okay. Now, which units up to 34.5? The ara! Okay. My first option analysis is wrong because this is 2, right? 2. If this is 2, this is a 34.5 degrees Celsius. This is the final temperature of the water. And if this water will transfer heat to the metal, then this will become also the initial of the metal. Dara di ay. Okay, so kung gibalik awkward na siya. Okay, awkward, meaning mura siya something ba? I smell something. Uy, di siya appropriate. Because here is initial manggoya. Initial po dito sa mura magdili siya match. Okay? Sometimes things like that having problem solving. Sorry talaga, guys. Okay? Ganon. Okay. Imagine lang, guys, kung in-ani ko mo face examination, how much mo sa examination, maratong lang ko, diba? Pag itigil na siya examination, wala na akong na-panic. Diba? Okay. So saan na lang mo, kung wapay theory, ang examination, hagbong din siguro si Sotero. Okay, dito maghibog guys sa computations. Okay, so 115 minus ano siya, 34.5 degrees Celsius, transfer na siya. Yan final sa water, most of ang initial sa metal na siya nagkabalhin. So 34.5. Sometimes you will feel the awkwardness. The way you substitute, the way you, basta ma-feel naman, alam mo naman, kwaki, something like that, baki. Hindi mo siya work, ano yan, ba, mas meron sa mo, the same as making an article, making a report, we use English terms, and it looks like it's not sounded well, you will hear, things like that also in math. Okay? Hindi mo siya bilagin siya, ito ko nito subuna na ba? Okay, that's why the action of review is very important. Maximum of 2 reviews, but for the examination, only 1 because it will take time, right? If you have so many time, then go review a lot, but usually to compensate your time, review only one time, then go back. go to other questions that is easy to solve. Don't stuck up to the difficult problem. Your time will be consumed there, and there's still so many questions ahead. Things like that, okay? So, ganun siya. Okay, so 115 minus 34.5. Okay. The final temperature of the water will also be the initial temperature of the metal because they are transferring heat with each other. Very clear. Okay? So 115 minus 34.5. 80.5 ang iyang temperature difference sa metal. So we have now having 80.5 here. Oh, 80.5. Now guys, in your Q metal, you still have the Q metal which is unknown, question mark. And we still have the CS question mark. But the CS is the one we need to know. Then compute for the CS. CS by algebra. Okay. CS is equal to 4.82 grams times 80.5. What is the unit of our 80.5? This is Celsius. Of course, this is temperature difference. And now our numerator will be Q metal. This is the Fury comes in. Fury. Okay? Because you said before, the Q of the metal is equal to the Q of the H2O. The heat of the metal is equal to the heat of the water because the water will absorb the heat from the metal. Okay? And the metal will release its heat. So they are in equilibrium during the heat transfer. So the Q metal is also the heat of the water. The substitution is 849 joules automatically here because they are equal in Fury. Okay? This is the time when your analysis comes in. Okay? 849. Okay? So what is your specific heat capacity or specific heat? Okay? Ganon. So 80.5 times 4.82 mga palangga is equal to 388.01. So 849 minus 849 divided by 388.01. So we have 2.19. Okay, 2.19 ang atong specific heat capacity of the unknown metal. Okay. 2.19. So the unit will be joules. Joules. 2.19 joules per gram degree Celsius. So in this particular problem, it needs 2.19 of heat energy of the metal to raise the substance metal at 1 degree Celsius. Like this. Okay? In here, this is your problem. Now you'll try to think another theory involves for this. 2.19, okay, the metal. Okay, you said like this. And then you have a specific heat of water, 1. Okay, like this. Okay, 1 calorie gram per degree Celsius. Water is 1 calorie per degree Celsius, but take note that is calorie. And then if convert the joules, 4.184 joules gram degree Celsius. Bear this in your mind, guys, that all metals, take note, this theory part, all metals have always lesser specific heat capacity compared to the water. Again, all metals, okay, have lower specific heat capacity compared to water. It's always lesser to 4.184. Take a look here, 2.93. Why? Why gayon? Okay? Why? Because, for example, if you heat the water in the heater, okay, with the same temperature, you get the point? Say, for example, I will get a diamond, or let's say a gold, I buy in the market, okay, and I'll try to heat the two, the water, okay, the water and the gold, something like that. You get the point? Okay, so you need a higher temperature to melt the gold. You get the point? Correct ba? Kaya experimental para mababatundaan. Okay? You get the point. So, muna na siya ang melting point because you melt the element. Okay, so, or you can say also that let's search for your specific capacity. And you need to take note going back to the formula. Q is equals to mCp dt. Like that, okay? And then if your specific capacity will increase, your heat also will increase. Now, if your specific heat is lesser, your heat also is lesser. Meaning to say pala, sorry, you need to heat in a short period of time, okay, for the metals compared to the water to obtain this kind of specific heat. You get the point? Because of this formula. Okay? Tinuod na, ihitan mo kadiyot, melt dahil ang element. Charot. I think so. Kaya kung siya, conductive man siya sa heat. Oh yeah, of course. In the theory also, metal, metal, okay, the metal is conductive to electricity and also the heat, something like that. So the more the heat is still lower, the more it will be converted to electricity. Compared to the water, it will just reach to 100 degrees Celsius pa siya. Una pa siya mong init pag-ayo. But for the metal, lower than 100 degrees Celsius, it will be heated or it will be melted. It will be melted. Okay? So, it will require only a lesser temperature and a lower temperature for the metal to melt. Okay? Or to have a specific capacity like this. Okay, taas mo rin yung specific capacity. Ganda na chupa-chucho, di ba? Lower yung specific capacity, meaning to say, it also requires a lower heat to melt compared to the water, something like that. Okay, this is theory, ha? Okay, but take note na lang siya guys, all elements have lower specific heat capacity than water. Imagine the water will boil at 100 degrees pa siya, but elements is lesser than 100 degrees Celsius. Melt na ang kasagaran sa mga metals. Because metals are conductive to electricity and conductive to heat. Okay, that's the point. Muna siya kay, kung ano siya, di ba, kung i-measure po niyo ang thermal conductivity. Kasi may formula sa thermal conductivity. Why I relate to thermal conductivity? Because this is thermal, meaning heat. And then conductivity to conduct, meaning thermal conductivity, the other elements or metals to conduct heat. Okay, so let's know the thermal conductivity, the value of K. Ganon. Ang saan ito ma-formula? Nakalusod na. Ay, charot. Sige. Nakakaloka. I still have to connect that one with the thermal conductivity. Okay. Ganon. So, if all metals have higher resistance, mean to say, it has lesser thermal conductivity. Of course, resistance is to resist man siya. Okay? So, if you relate that also to heat, pangyara siya. Okay? Ganun kaya properties na sa metals ang conductivity to conduct heat and to conduct electricity. So, muna siya nitabo. Okay, ana lang ang thermal conductivity guys. K is equals to, I forgot, but if I will have the other formula, I can derive something like that. So usually, ana akong style na was in college. I memorize, but sometimes my memorization fails, especially formulas and figures. I don't like really, guys. As I told you, I don't like math. Okay? I really love memorization and English. Okay? Trust me, reporting, verbal communication, hosting, MCing, declamation contest, oratorical contest, name it. As long as it is an English competition, easy writing, slogan writing contest, it involves, English. I love that too much. But it is math I don't like. That's why sometimes you will notice when I discuss, I easily got missed. Okay, but anyhow, I still manage also. So K is equals to, nakalimot ko, di ba? So I will attach this to the equation of the heat transfer. Nakatulog ka na, Q, ganon, di ba? Nakalungdom mo, ani? Ano mo ang Q, nakay delta H, ganon. Naman to siya thickness sa taas. So, ubos ang imong area. Ano ba? Okay. Dili din imong kuhan, change in temperature, ganon. So, Ano ni siya? Nakalimot mong po guys. So our thermal conductivity based on my connecting the dots will be equal to delta H times the thickness over the area, the surface area times the change in temperature. So this is the thermal conductivity. Ganon. Sa solid ni siya. Sa heat transfer through conduction. Okay, ganon. Now, yung mga kalay, yung thermal conductivity taas kayo, wala na siya specific heat. Hindi mo siya ibungkang ang delta H. Did the point? Since in the theory also, at constant temperature and pressure, the delta H will be equal to Q. So you will erase this delta H substitute with Q. Because the theory states, at constant temperature and pressure, the Q heat content is just equal to the enthalpy change, or the delta H. So kung ikutan na ito ang Q dari-ari. Kung kuya ng delta H, okay, now, notice the thermal conductivity is directly proportional to the heat, right? If the heat will increase, the thermal conductivity also will increase. Okay, now, substitute the formula of Q in this numerator. So this will become, makakuha na rin guys. Okay, wala sa libro ha. K is equals to MCP dt. Mo siya akong ganun sa una. Na-practice naman ako sa una guys na mag-ako ba? Sometimes, makakuha ko mga ako or June. Charot! Okay, charot lang. Okay, MCP, delta T, okay, times the D. Wabiyanin guys, kaya siya, yung interpolation ba yan ang formula sa thermodynamics niya, kaya siya, chemistry pa ba yan siya, general chemistry. But akong i-connect ang general chemistry to the thermodynamics and the interpolation as well. Because there's heat transport phenomena, right? Okay. Now if I transfer the formula of MCP dt to the numerator times the times T over area delta T. And then it's also the same that if your specific heat will increase, your thermal conductivity also will increase. Ganon. So meaning to say, the specific heat of the water is always higher than the metals at the same time, and also the thermal conductivity. Because in the formula, that is directly proportional with each other. Oh, ganon. So the more, the higher thermal conductivity, the more also you have higher specific heat capacity. Because of this formula. Okay? Okay, master this relationship theories because it always comes out in the examinations. And then something, what will happen to the blank if the blank will decrease? What will happen to the blank, blah, 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 blah. Remain constant, ganon. So, the problem solving will never work there. It's theory. Okay? What will happen to thermal conductivity? Blah, 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 blah. Ganon. It will not be affected, remains the same. It will be decreased, it will be reduced, none of the above. So this is the K technique for that kind of theory, okay? And there's a lot, not only this. Okay? For example, what will happen to the pressure if you increase the velocity? Okay, if the liquid going to the pipeline is increased, what will happen to your pressure? Ganon. If the diameter will increase, what will happen to your velocity? Ganon. If you increase both the velocity and the area of the pipe, what will happen to your pressure? And then, the temperature will be affected or not? Ganon. Diba? So, wala siya yung mga operating conditions and operating parameters. Usually, there's a physical property siya. Okay? So, mga extensive property. Okay? Or extrinsic property of matter. Ganon. So, nakuha na nato guys, 2.19. Any questions so far? Mga palangga? Nothing? Okay, question na muna yun. Okay. Para ato nang hayabuman. Charot. Kakalaw ka. Okay. Then I also would like to emphasize this one also. I did not teach you this kind of formula. Natuog naman dito sa una guys. Uy, makakuha rin gagawin ko. Charot! I mean, kanang mura ba ako kabantay ba na ipag-discuss ang uban? That was 20 years ago na. Pero, makinundong ba yung akong i-discuss, di ba? Flashback ng brain cells. Pero, naiuban ba makinundong? Char. For example, natin nga rin ang formula. Kung alam, ako muna sa buong methane. Ang methane lang. Okay, so, methane Hydrocarbon, methane, or natural gas plus oxygen gas to produce carbon dioxide plus water. Okay, balance the chemical equation. Ayan. I-balance mo na siya per guys, ha? This is complete combustion. The first identification of a complete combustion, there's no presence of carbon monoxide and there's no presence of carbon solid in product. Okay? Because in complete combustion, it will not be fully converted to CO2 and H2O because you have insufficient amount of oxygen gas for the rapid oxidation of your combustion process. That's why incomplete combustion. Most of the incomplete combustion will be found in the topic of Hess law. You know Hess law? Hess law is the constant heat of summation, in which your enthalpy change for the reaction is equal to the changes of the heat involved in your total overall chemical reaction. For example, if I have delta H of the reaction, okay, that is F, or delta heat of formation of the reaction, is equal to the change of delta H, let's say 1, plus delta H2, plus delta H3, plus delta H4. So this is summation, constant summation of heat. If you found like this is already under Hess law. Okay? HESSLAW. Okay? If you don't find too much number of this, only one, so that is not yet Hess law. Okay, that's the ordinary thermochemical equations only. That doesn't involve the Hess law. Basta dagan yung mga delta H na siya Hess law. Okay? And then, we can compute that in also the other way around. Kung ang hitong change na siya. What is the enthalpy change and the overall chemical reaction? Because change meaning it is the, in math, change meaning difference. Right? So, ano na siya? Delta H, F is equal to the summation of the heat of formation of the products minus the summation of the heat of the formation of the reactant. Okay? It depends on the situation. Okay, what particular formulas you'll be able to use. Okay? Now, if this you have like a CH4 gas plus oxygen gas is CO2 gas plus H2O gas. I remember the delta H is negative 890.4 kilojoules. Okay. I memorized this when I was in college because methane is the starting point of all hydrocarbon. Starting point means the basic, it will start to methane. Methane, ethane, propane, butane, heptane, hexane, pentane, octane, nonane, decane, dodecane. Something like that. So CH4 is the first one. So I said to myself, I should memorize this. Delta H. The delta H of the methane is negative 890.4 kilojoules. Okay? Muna siya. So, if you memorize this, usually mag-give it na siya. Okay lang din memorize it, pero ganahan ako memorize it ako. Okay? Delta H is negative 890.4 kilojoules. Now guys, this is exothermic. Okay, exothermic process. Okay, the delta H meaning spontaneous. Okay? Spontaneous meaning irreversible reaction. Okay, like that. Now in this chemical reaction only, there are a lot of questions to be raised in the question. What type of chemical reaction is this? Aside from knowing this is a complete combustion, your answer will be spontaneous chemical reaction, irreversible chemical reaction, like that. And what is the process? It is exothermic process, meaning the heat is released. Okay, the heat is released, okay, from the surrounding. Okay, get the point? Okay, negative lang siya, guys. Okay, negative. You get the point? Pag-release, ano niya, gi-absorb sa reactant. So that is heat absorbed by this reactants. Yung nakakaloka. You get mga palangga. Diba? Heat
The
release.
Bluetooth device is ready to pair.
Hello? Heat release na siya, guys. Heat released. Okay, negative man siya. Okay, exothermic na niya siya. Heat absorbed, meaning positive delta H. Because it is being absorbed by the system. In here, guys, the system is your reactant. Okay, the surrounding will be your product. Okay, for example, this is process. Okay, process. We have the system and we have the surrounding. Okay, in chemical reaction point of view, the system will be your reactant. Okay, you get the point? Chemical reaction point of view. Okay, and your product will be your surrounding. Okay, now the terminologies will be used in the question in the future will be like this. What is a type of process? If we are referring to system and surrounding, which is normally thermodynamics, state functions lang siya, katong mga internal energy, okay, may ano lang siya, enthalpy, entropy. But kung chemical reaction, what is the reaction, type of reaction for the chemical reaction having this like this? Okay, reactant siya, base, product, base, mga ganon. So that's why in the book, as you can notice, if you scan the book, okay, scan the book talaga, okay? Ako na din siya naaninaw because when I was in college, I would go to the library of my use of second time. Until such time, I will sleep in the library. Okay, just scanning different types of books. Okay, so I read a lot. Okay, something like that. I don't solve a lot, but I read a lot. Okay, like that. Okay, now, the reaction point of view man siya. So, heat release or absorbed by the reactants, it's gonna be like this, CH4 gas plus oxygen gas plus delta H. Because it is being added and absorbed by the reactant. Okay? Since that is added and absorbed, that is endothermic reaction. Okay, endothermic. Okay, ganon. Now, here in the product, there's no delta H. Okay, now since you absorb the delta H, so your surrounding H will be negative because it is taken away. For example, I have money, 20 pesos. If somebody taken my 10 pesos, I have negative 10 remains, something like that, meaning minus. If you take that away, removal, that means it will become lesser. That's why negative. So the same thing here, that's why negative delta H in this situation sa product. Okay? You get the point? Since this is chemical bonding. You know chemical bonding. Okay? Doon kita timaan guys ha, basta totally sa chemistry. Okay, chemical bonding. Okay. Chemical bonding, we have breaking the band is the opposite. So breaking the band meaning splitting the molecules, right? Splitting the molecules, or in short, decomposition reaction. When you decompose a compound to several products into elemental constituents, that will become decomposition reaction. One type of your chemical reaction. Okay. Now, conditional thing, i-memorize. Okay? I-memorize na mo siya because this is the generalities, not specific. Okay? So, saan mo yung pag-memorize? Okay, i-memorize yung timan. Chemical bonding gani, exo. Okay? Breaking or splitting or decomposition is endo. Exo, negative delta H. Endo, positive delta H. Okay? Added and absorbed. Release, level of a negative. Okay, something like that. So in Greek language, endo means taking in. Okay, and then exo is taking out. Something like that. Okay? You get the point? So meaning pala, ang taking out kay EXO, taking out ang heat. Kay heat is an energy. Mubitong na negative kay taking out the energy, that's the EXO. Okay? And then endo taking in of the heat in which received by the system. Okay? Alangan ang surrounding mo yung taking in. Yan ang bumihatag ng niyang heat. O diba? Ganon siya. Pagsagot, gamit kayo siya sa thermodynamics pero magkabawa ka sa sign. Okay? So if your sign will be wrong, what is the, for example, what is the heat energy released? And then your answer is positive. Then you'll become wrong even though the magnitude or the value is exactly correct. Only the sign is mistake. It will become wrong. Okay? You get the point? Unless you will put also English, but the examination, computerized examination is not checked by hand. It's checked by computers. For example, my answer is negative 482, and that is exothermic. I will never put negative in my answer, but I will say 482 kilojoules, the heat being released. Ganon. Even though I will never put the negative, but it's understood that it is being released. So even though positive akong himutang, correct gabo na siya by technical theory. If I will never put the word, you put negative. Of course, by common sense, it's easy to put negative and positive rather than putting the terms or the sentence, right? But what I mean, if the examination is checked by hand, it's still correct. But if computerized, it never be. Okay? Because it's computerized, the one who check has no brain cells. Okay? It's only formatting by human being. So if the feeding of the formatting is wrong, it will be entirely wrong from the 1 to 100. Kung magkabuang yun ang computer. You get the point? So magkinabuang siyang check from item 1 to item 100. Even though your answers are correct, it will become wrong. And we cannot do about that because that is computerized failure. Okay? Look at the point. So we look dito ang hand checking. Okay? So because the one who check is the people or the instructors or whatever, and they can give you points, something like that. You get the point? Ganon. Diba? Sometimes na siya, dahil sa delta H, negative na siya dari ari. Or gano'n, chupa-chucho. Okay? You get the point? Gas ni siya guys ha? Okay, gano'n gas. All are gases. Kaya water will vaporize na po siya. Okay? Liquid to steam during vaporization or evaporation. Okay, you get the point mga palangga. Any questions so far? Na may mga question? Okay, thank you so much. Bye-bye. God bless everybody. If you like this video, then you can comment down below. And then you can subscribe to my channel if you like. And then you can also click the notification bell for some news updates if I am a singer. Bye-bye. God bless everybody. Okay. Nakakaloka.